Hey Alex, so I wanted to give you a little bit more to think about with this red-green block problem. So when I emailed you earlier and said to think about it recursively. So what I mean by that is if you start off with, let's say, 4 red and 6 green, and level 1 being the top block, so there's just one block at the top. So if you pick a red block to be the block at the top, then you'll have 3 red blocks left and 6 green blocks left at level 2, right, where you can have 2 blocks. If you pick the green one, you'll have 4 red blocks still, but 1 less green block. Okay, and then when you're at level 2, if you fill the row with 2 of the red ones, you'll go here. You'll be 1 red, 6 green at level 3, and so on. Okay, so the general idea is you're going when you go to the left on this tree, you're setting the first variable here, your number of red blocks, to red minus level, because you're taking away, you're using up red blocks for that level, right? And then green stays the same and the level increases. And then if you're going to the right on the tree, the number of red blocks stays the same. You're using all greens for that level, so your number of green blocks decreases by the level, and then you increment the level. Okay, so that's like a general idea of how to do it. You're going to have the issue though of what happens if this is not a triangular number. So what I mean by that is 4 plus 6 equals 10, right? So you have a triangular number of blocks. So the triangular numbers are 1, 3, 6, 10, and so on, as that you would have if you had an exact number of blocks for a tower. Okay, but you might not have an exact number. So as you mentioned before, the way that you get a particular, your number of blocks is going to be related to this triangular number, to h, the height of the tower, times h plus 1 over 2. And what you can do is, with a little bit of algebra, you can figure out what h would be for a particular b. And then if we take the integer part of this, that's going to give us the highest tower that we can build with b blocks. So what you can do with that is you can, as a first step, you can say, okay, well, so one of the examples is with 9 red, 7 green, and as your starting point, you can say, okay, well, I know that the closest triangular number below this is 15, so I'm going to split and as my step 1, and my only possibilities for this number of red and green are to, that add up to 15, are if I have 8 and 7 or 9 and 6 to start with. So then basically you're building 2 different trees. Now the number of trees is going to depend on what triangular number these add up to and how many of each color you have, right? So you have to think about that. But in general, the way to think about these problems is you want to break it down into simpler problems. You also want to just ask a lot of questions about the problem. Like how high can the tower be? What if I have this many reds and this many greens? Try out a bunch of different scenarios. Try out all the ones that they give as examples and see if you can build a tree out of each one, and look for patterns, and then think about how you can program it. Okay, so work through that, work on some of those problems for a little bit. It's a real research problem. You want to really think these things through and spend a lot of time on it. It's not like one of these littler exercises that we've had in the regular course. So give it a lot of thought and see what you can come up with.